Hello everyone, my name is Fahim Ahmed. Today I want to discuss about the basic and inner application of operational amplifiers. Operational amplifiers or op-amp have two input terminals and one output terminal. An operational amplifier has many interesting properties. First of all, an operational amplifier has very high open loop gain. And an operational amplifier has very high input impedance, which ensures zero current flow into input terminals. Output impedance of operational amplifier is very low, which allows operational amplifiers to drive heavy loads without any voltage drop. And last but not least, an operational amplifier has an infinite bandwidth. For an ideal op-amp, the open loop gain is infinite and the input impedance is also infinite, but output impedance is zero. In open loop configuration, this is the expression for the output voltage. Here V plus and V minus are the non-inverting and inverting input respectively. They are also called the positive and negative terminal input voltage of an op-amp. And here Vs are the supply voltage and A is the open loop gain. For an ideal op-amp, open loop gain is very high. This causes the output voltage to saturate. The saturation voltage is usually a bit smaller than the supply voltages. If the non-inverting voltage is greater than the inverting input voltage, then the output voltage will be positive. Otherwise, the output voltage will be negative. This is an operational amplifier circuit in negative feedback configuration. Output is connected to the negative input terminal through this path. Let's assume the voltage at positive terminal is greater than the voltage at negative input terminal. Then the output voltage will be positive. And a part of the output voltage will be fed back to the input terminal via this feedback path so that eventually the voltage at the positive input terminal and negative input terminal will be equal. So if the positive terminal is grounded, then the voltage on the negative terminal will be 0 volt. This is called virtual ground. A virtual ground is not real ground as there is no direct connection to the ground. This is a circuit of an inverting amplifier. Here the positive terminal is grounded, so the voltage at the negative terminal will be 0. Here the current at the input terminal is 0. So if we apply KCL on the node between R1 and RF, this current will simply be equal to this current. So this gives us this simple equation, and by simplifying this simple equation, we can get the expression for the gain, which is simply equal to minus RF divided by R1. Here the minus sign indicates the output being inverted. This is a circuit of a non-inverting amplifier. Here the positive terminal is grounded to the V1 voltage source, so the voltage on the negative terminal will be V1. Here the input terminal current is 0, so if we apply KCL on the node between R1 and RF, this current will be equal to this current. This gives us the simple equation, and by simplifying this equation, we can get the expression for the gain, which is equal to 1 plus RF divided by R1. Now, for example, if we take R1 and RF 100 kilo ohm and 200 kilo ohm respectively for a 4 volt input voltage, we will get output voltage at 12 volt by using our earlier derived equation. So this is the lecture for today. Thank you for your attention.